This is the accessory bag for our W806 instrument. Desiccant, the tube and the bracket of this balance. Refrigerant. Let's open the accessory box now. Check if these accessories are complete. This is a tray. The scale of the scale. This is the intake air source. Air supply greater than 0.4 megapascals. The trachea of these two drying components. It is possible to connect at will. And then this is the drain. This drain is the liquid that drains the coolant. If you add too much coolant, will come out of here. Then this is the communication interface. And this is the power source. Then these are all spare. Like 10% humidity. There is a 2% deviation. We assume that the desiccant has failed. Then we can replace the desiccant with a new one. Then screw it back like this. These two pipes are not oriented. Both sides can be connected. There are 6 pipes on both sides and cut a little bit. Note that this is the entrance. This is out. And now we're going to install it on the instrument. The intake direction here is from this side. Then we catch air and go in here. And now we're not screwing. Let's lift this valve up first. Then follow the direction indicated by this and keep twisting on the left. Adjust to 0.4 megapascals. Here you can see that there are more than 4. Find the shipping USB stick, the file software in the delivery. Then copy it. Copy to desktop. Find the shipping software. Put the file. Copy to desktop. Then find the software of the instrument. Open double-click. Language can be switched. And now we find this debug and calibrate. Now we're going to connect to communication. Click on this computer. Then find Management. Find Facility Management. Find Port. Then find the USB cable of the instrument. Unplug this port. Here you can see that there is a text update on the COM port. This is RPL23. The corresponding port is COM3, so we choose COM3 here. Then refresh. Then take a look at our port here. We just plugged the data cable of this instrument into the computer. If COM refreshes here, there is COM3. It doesn't have an exclamation point, so it's connected to the computer. No need to install that driver. If not, the COM3 port does not appear. We plugged it into the computer. So now we're going to open the driver of our shipping software. So we need to install this driver now. Click Yes. Now we have completed the installation. Go back to Facility Management after installation. You can see that this port COM3 has appeared. Now let's unplug it, then plug it back in. We can see that COM3. That proves that the drive has been activated. Select COM3. That's the port of the instrument. Click Reset. Well, we return to tested the interface. And now we see, this real-time data, it's coming from the instrument. That proves that the instrument has been connected. Communication is okay. This is the test interface. Look at this level with warnings. Now you need to add liquid. Now get our coolant out. A liquid injection port for a coolant. Now we add refrigerant to this one. Add 30 milliliters each time you add it. Take it and poke it into this hole inside. Then add slowly and slowly. We add 30 milliliters of liquid each time. Also observe the warnings of this setting interface. We can switch and refresh the interface while adding. You can see if the liquid level here is normal. Find here. Import data. Then find the shipping software we just used on the desktop. Here's a permeability experiment. We choose this, then open. Import successful. So this is our data, including temperature data and calibration data. This is our data before leaving the factory. Now we add refrigerant to this one, adding 30 milliliters each time. Then move this mouth pair. Take it and poke it into this hole inside, then add slowly and slowly. There are warnings in the settings interface. Refresh the page while adding. It shows that the normal state is that the liquid addition is completed. Open the lid, and we're going to install the scales inside. Now let's start dismantling. Now let's take out the main piece of the scale. And now we can put that aside. Put the scales in. So be careful when putting it away, to align. You can be careful. We aimed at that hole and found. So now we adjust the release by hand. Put the balance in the corresponding position. This process must be paid attention to. Don't press down too hard, because the load-bearing module below is very sensitive. Put it down, so we're in the middle here. It has been held up by the tray. If this green sealing ring falls out, we can smear the grooves with some sealing paper. Now it won't fall off. Install it back like this. Now we install the corresponding screws back. Now we open Debug and Calibrate this correction interface and find the balance. And now we open the split level. You can see the level of our water instrument is in a position relatively close to 0. How should we adjust the instrument when the instrument is placed on the table after we start this level? Suppose it's a large number, so let's try to get Xi as close to 0. And we now see these for below, used to fine-tune the level of the balance inside the instrument. About the 4 feet, use that screw to turn it up. Then we have to observe the XY value of the screen while adjusting the process. XY value, the range we adjust is plus or minus 0.5, as close as possible. If our hands could reach in, then we can also fine-tune the 4 inside. Fine-tune these 4. Bring its XY value closer. Try to adjust to 0. Plus or minus 0.5 is the best within this range. And now we're at this debugging interface. Continuous left click on a place. Now we have an interface like this. The next step is the balance weighing interface we want. Reset this. Wait for this rotation to stop. And now we see that this rotation has stopped. So now we take out the turntable and put it on. And now we map the position of 1 to here, because it has now been reset. And we're going to put the number 1 here. Now put this thing on. Find the inner hexagon of number 5. Fix it now. This is our sample cutter. Pull its latch out first. Use distilled or purified water for experiments. This water should be added to this cup. Don't get water on the edge. Then if there is water, wipe off some moisture on it with a tissue. Before loading, we can use this sealing paper. Upper layer of sealing paper to ensure the tightness of its sample. Pay attention to the sample. If your sample has front and back sides, the test face should face up. We see that the bracket is raised. Follow the scale below this tray. This position of the balance is weighing. There is a distance apart. Before putting the sample into the cavity, let's take a look at this debugging interface first. If it's balance rack and its bracket tray, and the tray of that balance, if it is not separated, then we can click this. Click Reset. Weighing tray for bracket and lower balance. It has a certain height distance. Now we see that the height is enough because we can put samples on it. Be careful not to move too much when placing it. Be lighter, otherwise the water in that cup will get on it. Now we can see that the following is followed by no contact with him. So you can put it down. We can put it in order. Now we can put the lid down. Now we click Add. Then select the water model. That's what we do, weight loss. Then the temperature is 38 degrees. Enter 10 humidity. Area of 33. Number of times is based on the sample, so now we choose 12. Then the number of samples is 6 cups. So choose 6. Testing standards can be based on your needs. For example, the standard we use now is based on GB. Now we can put the entire information of this sample. Let's save this information preservation plan first. I just use it as a name to identify myself. Then we say information. Then it has been set. We can meet this standard here. After we click this save. Here we have just used. I have created a test method for this. Then we directly choose its words. It will also be available for the next test. And then information about each cup. We can fill in the test unit. Sample information is filled in as required. There should be no vibrations during the entire test, including the vibrations of the table, which will affect the balance. The above instrument cannot prevent Dunksahue from affecting the test results. After starting the test, now this curve starts to appear, and then every unit of time. It's because he's a weight loss method now. In his cup sample, the cup of water will fly and slip. Then its weight is dropping, each round per unit time. The frequency of this decrease. That's his result. This is the information content corresponding to the report interface. This is before the instrument is tested by the weight gain method. We need to confirm the liquid level is in these two ranges. One is a range between the upper and lower liquid levels, to make sure it doesn't exceed this. Can't go lower than this range. Then we can add water to it. Add here until appropriate. So now we can click Add here to increase the weight gain method. Then select the previous weight gain. The temperature is 38 degrees. Humidity is 90%. Pour this desiccant into the cup. We want to make sure the desiccant is effective. It's almost like this. It is about the same if it exceeds 2/3 of the capacity under this cup. Okay, make sure it doesn't top like this. This inner wall needs a sealing grease. Make sure it's well sealed. We can press it with our hands like this. Then just screw it back. Because what we are doing now is a standard sample, so we chose 12 cups. If there are 6, choose 6. Okay, let's save this information for now. So that's one of our strategies for gaining weight. Then we filled in some parameters earlier. Then save. We can see it has appeared here. Some parameters we just created. Then the same. Fill in according to the information name of each sample. Save information. Yes. So here's our test report interface. This way we can see the corresponding curve. Each round it weighs. Then correspond to the curve above is our weight change weight. And this result. The weight curve keeps falling. The result is a relatively stable. The result is stable. We see this water, this result. This curve is relatively because stable. Its curve is normal. Look at number 2 cup, number 3 cup, number 4 cup, number 5 cup, number 6 cup. Then it's normal to get this result. This curve is called the change curve of weight, and this is what we came up with. The result is very stable. Is this a better one? We can review the report first. Preview it first. This is the format of the report. We can see the corresponding results. Curves will be displayed. Then here is the usual download here. We can click to download. Just get your report. Then you can choose. You put it in the corresponding file location on the desktop. Then you can save it.